Hello, everybody. Welcome to today's talk about, not all time series are equal. We're going to talk about what we have seen in the last few years about especially our industrial customers, what the challenges are, especially related to industrial IoT use cases to store and analyze the data in these cases. Let me start by introducing myself. My name is Georg Stra. I'm the product manager for CrateDB Cloud, our managed offering. And I brought with me one of our customers, Alexander. Do you want to introduce yourself?
Yeah. Hi, my name is Alexander Mann. I'm with TGW Logistics Group. We're building automated warehouses and distribution centers all around the world. And I will tell you more about that later.
So we're going to start with a more general intro. As I said, the focus of today's talk is about the challenges in storing industrial data, but maybe just a few notes on what CrateDB is doing. So CrateDB, as I said, is a database, and there's three things that you need to remember about it. It's fast, it's flexible, and scalable. What do I mean by that? You can run really fast aggregations and queries with CrateDB. It's flexible. It's using standard SQL. You can use directly ingest your JSON payloads and analyze it with it. And it's scalable. You can start with a single node on an edge device, but you can scale it out to multiple hundreds of nodes to really build large data systems. But I don't want to talk too much about the product first, but really about the challenges. What I brought with me today is a use case that we have seen 3 years ago. 3 years ago, we were challenged by one of our prospects to build a system to bring together the data that they really need to use for an industrial use case. Their challenge was that they have a production process where they're collecting data, measurements on the machine itself, but they also have data from a quality assurance process that happens days after. And in order to really analyze this data, you need to combine them. So in this case, just to make the ground, we had like an PLC that was delivering around, let's say, 50 variables at 100 hertz, so about 5,000 metrics per second. We had a measurement technology that really collected high-frequency data for force, for accelerations, and for different kind of data that was measured really in the production process. We had the ERB data from production order, but also the bill of materials, because it was interesting what kind of materials were part of the process and what batches of these materials were part of the process. And we also had quality assurance data, as I said before, that really where they measured the final outcome of the product. And together with one of our system integrators, we built this as a POC with an edge device. We were collecting the data, and we're really providing and then forwarding the data into CrateDB, where it was stored and could be analyzed by the engineers and data scientists of that customer. So if we go one step deeper, what kind of data did we see here? First and foremost, we have time series data. Of course, time series data is extremely important in IoT use cases. What are typical characteristics of time series data? They're typically append only. We have like a timestamp, we have a value. It's a very large volume often, so we're talking about lots of metrics coming in per second. So we have very high write rates. So what are the challenges for storing that and analyzing that? For storing, of course, you need a system that can handle that large write rates, that can keep up with that. But also, just storing a lot of data also costs a lot of money. So you need a system that is able to compress the data in a way that it's also cheap to store it and doesn't get too expensive too quickly. You want to have fast query performance because you want to build your dashboards on top of it that can query the data in real time. And you also need solutions for handling out of order data or missing data. Especially, that can easily happen. There's just a disconnect, a problem in the network, and you still need to be able to have the data to be ready to be analyzed. So time series data is important, but time series data without context doesn't really help you analyzing them. So what you also typically would need is some sort of master data that describe the source of the data, that describe the environment, that describe the process. And But those kind of data is often quite different from pure time series data, because there you have hierarchies in the data. Like, think about a shop floor, you have a machine, you have like a production floor, you have a site, and you want to be able to search the data that you need and analyze the data that you need. And in order to do that, you need to be able to kind of represent this data. And in this case, we have like a JSON example describing the data, but you also need to connect it with your time series data to really being able to analyze it. And last but not least, if you bring all that together, you also have, as I said, you might be using an edge device, but also other systems that bring in log data, that tell you something about something not happening in the system that is expected or not expected, that has quite different kind of characteristics because it's often very text-driven and it's not a numeric value. So you have high cardinality fields describing that data. And you still also need the ability to efficiently and quickly search on it and also correlate it together with the metrics that you are collecting. And as I said to you before, CrateDB is really a solution that is fast, flexible, and scalable. And we are addressing all these issues coming together by providing a fast query engine that you can run real-time queries on that collected data. We're doing that by using really efficient usage of indexes and columnar storage. So you can really do very fast aggregations on billions of records in sub-second. We are flexible in terms of that we're using standard SQL. So any kind of engineer that knows SQL, and that's, I'd say, a lot, can use CrateDB out of the box. We allow relational data with joins, but also you can directly ingest your JSON payloads. And we also do support geo and full text search on this data. Bringing this all together, we are compatible with Postgres, so you can use your standard tools, your visualization tools, your analytics tools out of the box. And we are scalable in terms of, as I said, you can use it as a single device, you can use it fully managed in the cloud, and you can start with a small use case, but scale it up to very big data solutions. But that's it about my product pitch. Let me hand over the mic now to Alexander Mann, who can really tell you how they're using it in a real-world scenario.
Thank you. So let me give you a little bit of context first. So today's automated warehouses are really complex systems. So we have a lot of components in there. You have storage solutions, like shuttle systems, mini-load cranes that operate the racks. You have workstations for the whole order process, picking, packing, decanting, that is either manually with warehouse staff or operated by picking robots. And you have many kilometers of interconnecting conveyor systems, pocket sorters, autonomous mobile robots that span distances you can't cover with fixed installations. And then you have a lot of software systems. You have PLC software that manages the lower level of those systems, of those devices, and material flow control software, warehouse management software that manages all the devices, that coordinates the system and manages the logistic processes. So we wanted to get a deeper understanding on how our customers use our systems so that we can give them predictions, we can give them recommendations, do forecasts, do retrospectives, and also the things that were mentioned before, predictive maintenance, simulation runs. And for all of that, you need data, a lot of data. You need the data from all those different data sources like PLCs, embedded controllers, all sorts of sensors, our own software, and even third-party software that we utilize in our projects. And all this data sits there in different formats, in different structures, in different places. So in PLC registers, in relational database tables, you have log files, you have all sorts of things where you want to grab the data from with various ways to access them, because you sometimes you have to poll the S7 PLCs with the protocol. You have to poll to Modbus devices. You can use OPC UR to get event-triggered information, or just query database tables or hook up to a message bus to get the data. And so we built a hybrid infrastructure where we can collect data, we can send it to the cloud, we can transform it there and store and stream the data forward. And what we did is we deployed a data flow engine to the site, either on industrial PCs on the field level or virtual machines on the software level, where we connect to those data sources and fetch the information depending on the source protocol. And then we're transforming the data into a JSON message that we can pass on to the cloud using secure MQTT. So that's pretty much a standard in all of those IoT platforms. And up in the cloud, we use the same data flow engine to get the data from the broker and enrich it with meta information. Like we also heard before, you need structure, you need the site topology, you need to link the data to the entities so you can use them further down the road. And last but not least, we can stream them directly using a message broker so that application can display it almost in real time or store the data in CrateDB so that we can use them for the long-term data analysis. Let me give you a practical example. So in automated solutions, it's of utmost importance that you know where all those load carriers are around and to identify them. You usually do this with barcode scanners connected to the PLC with Profinet. And within the PLC, data is stored in data blocks, and it's pretty much not accessible to the outside world if you don't have the specific tools. So what we do is we have our data flow engine and we deploy a script to that data flow engine that is able to read the data, pull the data from the PLC, and whenever there is a change, whenever there is a new read, the whole thing is transformed into a proper JSON message with human readable tags and enriched with information, where is this scanner, which PLC, where in the site is it. So this is how the message looks like, so a generic format where we can pass this on. And then we take this message and send it up to the cloud and then link it with a stream ID which links it to the corresponding thing in the site, so we know exactly where in the system was this scanner read. And then we store it into CrateDB directly as an object. So what CrateDB allows us to do is to take that object and directly put it into the database. So CrateDB has object columns that in the beginning you can have them dynamic without the schema, so you can just send the data in and it will automatically create the schema for you. Or later on, once you know your data, you can create schemas and you can have a column definition, and then this data is checked when you insert this to the database. So a quick recap. We read it from the PLCs, we transfer it to the cloud, enrich it with metadata, and then put it into CrateDB. And then we can take the raw data directly and use it for visualization. So we have built some applications that make it very easy to look at that data. And our backend works with .NET, and we can use the off-the-shelf NuGet packages for PostgreSQL and Entity Framework and all the technologies that developers are used to. And you can use standard SQL tools. Yeah? So you can perform your query, because what CrateDB does, it allows you to query inside of the object using virtual columns for each of the tags, and you can even do that hierarchically. And the cool thing is that you can do the same thing for the software. So the logistic process events, in this case a pick operation that was performed at one of our pick stations, we read from the message bus, we transfer it into a JSON message, send it to the cloud, and again store it into CrateDB. And this empowers us to have the data all in one place, in the same format and the same structure, no matter where it came from, if it's a sensor, if it's a PLC, if it's a software solution. And this then allows to use all the data later on together for various use cases. So we then take the data, we can post-process and create all sorts of KPIs and metrics, store them back to CrateDB, and then use the same visualizations to present that to the customers. And as it's standard SQL, it's a standard PostgreSQL, you can use Grafana directly or other data analysis tools, Tableau, ClickView, you name them, and you can directly work with them and visualize the data and work with it. Or like our data scientists, they use, of course, the things there, Python, Jupyter notebooks, Streamlit to create rapid prototypes. And also they can work with the standard stuff from Python and standard SQL to directly have access to the data. So you don't need to prepare it or do some kind of data warehousing for this. So yeah, that was a brief insight on how we use CrateDB in our systems to fulfill the vision of a connected warehouse. And I give back to Georg.
Well, thanks a lot, Alexander. We are at the end of this talk. I just want to remind you, I'm sure there are a lot of questions that we will just have the opportunity right now, but I also want to remind you, we are easy to spot. We have blue t-shirts if you have any kind of questions about CrateDB, also about the use case from DGW. You can find us here right now. Just look around you, you find one with a blue shirt, but we also have a booth at stand 254. Where we also will have 2 live demos tomorrow and also I think one today in the afternoon.
Quick question, Alexander. On the diagram you show, there was information that you read from the PLC. So is it more like a pull system or a push, where the data and information is being pushed through it, so you are getting the near real-time information on the visualization, on the decision-making layer?
So it's basically depending on the data source, if you can do push or pull. So for the software system, we push the data because we can send events directly. And in the PLCs, it depends on what you utilize. When you have the ability to use OPC UA, you also get events. But what we do is basically we're polling the information constantly. And whenever we detect a change, we then produce the message and push it. So it's almost like having events, of course, with a delay of 200 milliseconds. Yeah.
Perfect, thank you.
Could you elaborate a bit on the PostgreSQL interface? What does it offer?
So we, from the SQL dialect, we are really following or trying to follow Postgres as much as possible so that they can use Postgres compatible tools out of the box with CrateDB. We are not a direct replacement for Postgres, but we are getting better and better in terms of compatibility. Yeah.
Maybe to add a little bit to that, you can really, in Grafana, you just use the standard Postgre data source and you can just hook it up, and also in all the programming environments. So it's really very, very compatible in the things you need, and you have a good documentation on the Crate website where it is not.